Hello, let's continue our Sudoku adventure with Leftovers by GDC and Chinstrap. So pay attention, strap in. We've got irregular Schrodinger Sudoku. What does that mean? Well, in every row and every column and every bold outlined region, we're going to be placing the digits 0 to 6 once each. How are we doing that? 0 to 6 is 7 digits, and this is 6 long, this is 6 long. Some of these regions are 5 in size, some of these regions are 7 in size. This one I could see how to do, 0 to 6. But a 5-cell region having 0 to 6, that doesn't make sense, right? Well, it'll make sense in a second. We have these things called S cells, and S cells can contain 2 digits instead of 1. And it acts as if it contained both digits. Not like the sum or of them or anything. It literally contains both of those digits. So it's just like a bigger cell. Now it's up to us to determine where those cells are. But for example, this row could be filled with 0, 1, and then this could be maybe 2 and 3, and then 4, 5, 6. So now this row, as you can see, has all of 1 through 6 once each. Now in terms of the solution checker, as long as you have the correct S cells, whatever you decide to put in there won't be solution checked. It'll only solution check the big digits. And so I'm choosing to do center marks for the 2 digits that end up in the S cell, so you can kind of see what they are. And I'm also going to green it to remind myself that that one is the S cell, to distinguish it from just a normal center mark. All right. In addition to that, we do have these blue lines in the grid. These are region sum lines. So what you do is you split up the line into segments based on region borders. So when we cross a region border, we start a new segment. So this is a segment and this is a segment. And the digits on each segment have the same sum if they're on the same line. So within the same line, every segment has the same sum. So if this was, say, 0, let's just do 3, 0, then this would be a 3. 3, 1, this could be a 4, for example. All right. If we had an S cell here, like 3, 1, 2, then this could be a 6. This would be our S cell right here. Because remember, it contains 1 and 2, so the sum is going to be 1 plus 2 plus 3. And that's 6. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. So something to think about with S cells is we know that every region that is 6 in size has exactly 1 S cell in it. A region that's 7 in size has no S cells in it, and a region that's 5 in size has 2 S cells in it. Because we know that there's always exactly 7 digits in each. And so that means that in every single row and every single column, at the very least, we're going to have, in every single row and every single column, we're going to have exactly 1 S cell. So there'll be 6 S cells in the grid. We have to find where they are. But what I'm going to do is I'm going to use gray for not an S cell and green for is an S cell. And so we know that this 7-cell region can't have an S cell in it because it has 7 digits for 7 cells. So I'm going to use green for is an S cell and gray for not an S cell. Now I know that, I think this is a good way in. We must have an S cell involved in here somewhere. Because if otherwise we'd just have to do like 3 and 3 or 2 and 2. They'd have to be the same digit. But that's not going to work because it's in the same row. Rows can't repeat digits. So one of these will be an S cell. I'll just use kind of a slashed green to designate that. And that means the rest of the row can't be an S cell, so that's not an S cell. Now this region needs 2 S cells in it. And you can't repeat an S cell in the column. So this is going to have to be an S cell. And this might be the second one, but the second one could be elsewhere. But that means the rest of this row and the rest of this column are not S cells. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, so this has 5 cells. So it needs 2 S cells. One of them will be in one of these 2, and one of them will be up here, but not this one. And so the rest of this row is not an S cell. That leaves this to be the S cell for this region. That means that's not. That means that is. That means these are not. And it also means this isn't. So this is. All right, so I just got a bunch of S cells. Oops, there we go. Rest of this row isn't. So this needs an S cell in it. Right. Oh, sorry. The rest of this, I was going to make some argument about why this can't be an S cell, but the row helps. Okay, so we're just down to this little rectangle. We're either going to have S cells like this or like this. We don't exactly know how that's going to resolve, do we? All right. So now we've kind of laid that groundwork. I think what I'm going to do is I'm going to get rid of the grays so I can do other kinds of coloring. And we'll just keep in mind that the S cells are somewhere in here. All right, so what's next? How about this here? So the minimum, I need 4 digits on here because this has 2 of them. This has 2 more and they can't repeat. So the minimum 4 digits are 0, 1, 2, 3. That sums to 6. Since this isn't an S cell, the biggest sum it can be is 6. So minimum is 6, maximum is 6. That's what it is. So this is from 4, 5, 6. This is from 4, 5, 6. That's not a 6. So this definitely contains a 6. I'm going to use the corner mark in an S cell to say when we know one but not the other. If that means anything. Okay, so this is your classic. I mean, the title of the puzzle is Leftovers, so we should probably be looking at the law of leftovers here. What we're going to learn is that this cell and this cell have to be exactly the same. Why? Well, whatever this cell is, it's not repeated in the region. So it's not in any of these cells. But we know the column has that digit. So if it's not repeated in the region, it has to go here. So these two are exactly the same digit. I'll use purple for that, meaning this is a 4, 5, 6, but it's not 6. So this definitely can't be 6 because this is the sum of these two, which are not Schrodinger cells. And this is not Schrodinger. And so this is 4 or 5, meaning this is not. So that's our 6 here. Now this region needs a 6 in it. So this Schrodinger cell contains a 6 plus something else. What else can we do? Well, okay, so this needs to be 0 or 1. These can't be the same digit as each other, actually. I was going to say either they're the same digit or one higher. But if this was a 0, these would be the same as each other, and this would also be purple, right? So if this was 4, this would be 4, and this would be 4, or 5, 5, 5. We can't do that in this row. So that's not true. So this is a 1, and that makes this 4 and these 5s. Don't need purple. That makes that a 4. So now we know that this is 5 and 6, so we can scan it that way. There might be other things to look at here, like this. We know these two are the same digit. Let's just reuse purple for that. So this sees 1 and 4, this sees 5 and 6. So what's left? They can be a 0. They can't be 1. They could be 2. They could be 3. They're not 4, 5, or 6. Okay. 0, 2, or 3. 4, 5, and 6 are gone here. So our sum can it be lower than 3? No. Okay, let's think about it this way. If one of these was a 0, that means that this cell and this cell are the same as each other. And that doesn't work in a column. So it cannot contain a 0, meaning the 0 in this column is here. And so now this is 1, 2, and 3, so we got to do 1 plus 2 is 3. None of them are S cells. So that's not 3, which means that's not 3. The 1, 2 pair means that these are 0s. Perfect. Don't need them to be purple anymore. This row just has 3 digits left, the 0, the 2, and the 3. Do I have any restrictions there? I don't think so. This 1, 2 pair is interesting. So this can't contain a 1 or a 2. Sorry, this can't contain a 1 and a 2. Sorry, it can't contain a 1 and a 2, because that would break this cell. What do I do here? We know that one's not 6. Neither of them are 5. Maybe there's more I can get before I look at that. Right, okay. We have more law of leftovers here. This is kind of interesting, which is that these 2 digits go in this S cell here because they need to go somewhere in the column and they can't repeat in the region. So this definitely contains a 3, meaning that's not a 3. But also that means this is the 1, 2 that goes in here. So whatever this is goes in here. That's a 1, 2 pair here. So this is not a 2, making this both 0 and 3, making this the 2. So now this isn't 2. Okay. Still don't really want to think about this. I'm hoping there's more Sudoku. So this column is then, so we have 1, 2 pair plus 0, 3. This column is 4, 5, 6. So we have 1, 2, 4, 5, 6. This has to be the 3. And that leaves 3 digits left for this column. We need a 2, 5, 6. This can't be 5 or 6 because of this, or the 4, 5, or where are the 5 and 6 reds coming from here? The rest of the region. Oh, I see. So this is a 2. Right. That we could have just finished this region with the 2. I didn't notice that. That makes this both 5 and 6. Okay, so far so good. This has 5 and 6. Yeah, that we could have done more law of leftovers for that. Okay, there were a lot of ways forward from there. Maybe I should be looking at more of these regions, but I'm not seeing it. What's the right question to ask here? 0 goes in one of these two. Okay, I don't think we can put 0 on this region sum line at all. It's the same reason we couldn't put it on here, right? One of them will be an S cell. Obviously, you wouldn't put a 0 in the non-S cell. How would you add to 0? But in the S cell, if you put a 0, then whatever other digit you put, like a 4, would have to be repeated here, and you can't repeat digits in the row. So no zeros involved here. So none of these are 0, which means the 0 for the column goes here, or the region. And then now the 0 goes here, and zeros are done. Okay. What about 3? 3 in this row, one of these two. One of these two is a 3. Okay, this has to contain a 1 or a 2, because it has to go somewhere in the row. This is one of them. The other one goes over here. And then it contains 2 of... Oh, it doesn't contain a 5. Actually, 5 is placed. These two aren't 5, so this is our 5 for the row. Leaving a 4, 6 pair. Oh, it's really hard to scan S cells. This is 5 and 6, so this was always going to be a 4, and that's 6 now. And so now we know the digits that are left are 1, 2, which we use only one of, and then 4, 6. That's not 2, that's not 6. I got to put a 6 somewhere. The 6 goes here. Ooh. The 6 goes in here. Is it an S cell? No, it's not. Obviously, 6 plus something isn't going to equal a non-S cell value. So this is a 6. It's not an S cell, making these S cells. And this has to be 2 plus 4 to do that. So this is our 1. This is our 2. What's left for this column? We need a 1, 3, 4. That's not 3. So 3 definitely goes in this S cell. We place the rest of the 3s. Yeah, this contains a 3, so it's not there. So this is our 3 for the row. And this is known. This is a 1, because we have the 2 and the 4 and the 5 and the 6 there. That's not 1. So this is a 3 and a 4, making that a 1. That's 2. That's 1. Okay. So now this is 2 and 3. All right. So this row I think all the rows can finish. We need a 4 in this row. We need a 5 in this row. We need a 1 in this row. Wow, we finished. And it's the correct solution. That was an adventure. Yeah, it's been a long time since I did a Schrodinger cell puzzle, so that was neat. And I don't think I've ever seen the irregular regions where they're different sizes. That's crazy. Kind of blew my mind when I noticed that. But yeah, it worked out. That was neat. We had 2 S cells in the 5 cell regions, and we had no S cells in the 7 cell regions, and each 6 cell region had 1 S cell. All right, cool. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.